Hello, good morning, good afternoon, good evening, everyone. Welcome to today's webinar and discussion on how iSIM is powering going to power the micromobility applications. And to discuss this, we have a great panel here from across the value chain, across the ecosystem, starting with Mr. Lloyd Bonmarle from Kigen, Igor Tuvberg from Sony Semiconductors, and Ronnie Cohen from FloLIVE, and myself, Nisha from Counterpoint Research. So we're going to discuss today about obviously the connectivity, which is powering a lot of different devices and a lot of different applications, which have been never connected before, or have been connected but not that efficiently, which it could have been in future or right now. So there are different ways of connecting devices, different form of connectivity, different form of chipsets, architectures, and security frameworks. However, we will try to look at the newest solution on the block, which is iSIM, and we have been talking about eSIM. The eSIM era is upon us, and how the next form factor evolution in eSIM will drive these newer applications connectivity and how beneficial it is. So we'll discuss this today. So I'll kickstart with what we think as counterpoint in terms of different trends which are shaping this particular evolution. So what we believe, iSIM is a very ideal form factor in terms for SIM card and for the micromobility applications. And why it is so, we will see it in a bit. So if you look at the overall global cellular connectivity market, close to 9 billion connections we'll see by 2025, including IoT. IoT will be the fastest growing segment, which will be driving the connectivity across. And and what we have seen over the last 3 decades of the evolution of connectivity, the SIM card form factors have changed, as the devices form factors have changed. So right from 1FF to almost 4FF to soft SIM. Then we have eSIM, which is hardware-based eSIM, WLCSP form factors, MFF2, and now we are moving towards integrated SIM, where the SIM card goes directly into the SoC or a chipset as a software. So, which is also called IUICC, and I think this will help with a lot of different advantages, and it unlocks a lot of flexibility, seamless provisioning, security, and advantages which we'll see in today's presentations. So if we look at the overall eSIM landscape, eSIM is obviously happening right across consumer devices like smartphones, smartwatches, tablets, laptops, to IoT applications, and we are seeing close to 200 operators across 90 countries have a huge portfolio of certified modules, devices for IoT, which are ready for eSIM and also iSIM. And there are a lot of different module vendors which are also participating to accelerate this journey. And as we see, players like Kigen, Sony, and then connectivity players and platform players such as FloLIVE as well. So why iSIM is a natural fit for micromobility applications? If you look at compared with traditional SIM, there are a lot of benefits, like from provisioning, customer satisfaction, different opportunities it opens up because of the smaller form factor. It directly goes the secure element, the iSIM directly goes into the SoC. There is no separate hardware required, so the footprint is almost minimal, which also means we can have end-to-end security, greater scalability, and above all, the biggest benefit which we can see in micromobility application where the space is constrained, it's power constraint, cost constraints, and the advantage which micromobility applications bring is reducing carbon dioxide emission and having much more environmental friendly mobility application from moving from point A to B. And similarly, iSIM also, since it has hardly it has no physical hardware technically. It means it's no plastic SIM cards, no soldered SIM cards, and that means almost zero footprint, completely software based, and extremely low power. So it's natural fit with micromobility applications. And when you look at the overall IoT segment and how eSIM and iSIM fits into it, what we estimate Counterpoint is by 2030, almost more than 90% of the IoT applications will have some form of eSIM. It could be hardware-based MFF2 or WLCSP form factor, or it could be software iSIM, IUSCC. And we believe almost 48% of the IoT applications will have integrated SIM by 2030. And if you look at this particular distribution of the high volume, high scale IoT applications versus the iSIM penetration, smartwatches, drones, micromobility are the ideal applications where we'll see a higher adoption of iSIM compared to other applications which are more fixed, stationary, as well as less mobile and can absorb the semiconductor or chipset cost. So IoT, iSIM is very aligned in terms of which applications within IoT it can drive scale as well as benefits. And micromobility is one of those applications which is close to almost 75 to 80 million unit shipments per year by 2030. And the key growth categories within micromobility, we see the highest growth category will be obviously e-kickboards, almost 6x growth compared to 2020 within 2030, and e-bikes almost 3x, and scooters with not only in shared space but also in personal mobility space. We are seeing many e-scooters are having by default cellular connectivity, which connects to which brings in all the sensor-based information to the cloud for the OEM to give feedback to different users in terms of how the performance of batteries and battery management. And similarly, there will be newer form factors evolving over the decade, which will see, which will also drive significant growth, but they will initially remain niche for this decade. And when you see the distribution, how the distribution of micromobility market is, and what are these applications are mostly cellular connected because of especially in shared mobility format, where it's most of fleet management type use cases where the fleet owners like Bolt, Climb, they want to manage the entire fleet and locate where the particular I would say the e-bikes or the scooters are located, and track them and also help manage them efficiently. So the overall growth we see between 2020 and 2028 is almost 4x, and scooters and bikes will be majority of the share of this. So having said that, this gives a potential of how big the market is. Over the decade, we could see hundreds of millions of these shipments of these connected micromobility devices going on into the market, and all of them can benefit from iSIM capabilities. And to talk more about these capabilities, I would like to invite Loic Honavarle, who drives iSIM solution within these different applications.
Thank you, Neil. So yeah, pleased to be here, and I will just shortly load my presentation to talk about how iSIM is unleashing power in the smart mobility. So there we go. All right. So yeah, first of all, yeah, I'm Loic Honavarle. I'm leading the product marketing at Kigen, so both product management activities related to all Kigen products, as well as all the marketing activities. So I will go a little bit more into detail on the evolution of the SIM functionality within cellular devices, right? So maybe most of you have seen already this type of slide, but just a quick reminder on the key points and dates that we've seen in the cellular industry. So 96, we had the birth of notably the removable SIM that everybody knows into their phones, smartphones, dumb phones, and really a very wide adoption into the marketplace as the key to cellular networks. And really, I have to say, for a 30 years old technology, something that has been resisting quite well over the years around attacks and security issues so far. Back in 2016, there was a growing need for stronger, more resistant, solderable SIM. So that's the so-called eSIM form factor. And with that, and the inability to basically remove the card from the device, you had the need for remote management. And really, that started all with the automotive market, where most of the big car makers wanted to be able to control the connectivity that goes into their cars for two use cases: for telematics on one side, for interacting with their customer, as well as infotainment when you want to look at a movie or browse on internet using your car as a kind of a gateway to internet. So that really defined the remote SIM provisioning capabilities. And then really in 2018, Kigen notably launched the iSIM concept. So really around the reduction of form factor. And I think the key point to understand is that it's still the same hardware-backed security that is providing the SIM functionality. That is, it's typically a dedicated secure core that is running into a design. Let's say, for example, in our case here with our partner at Sony Altair, within the Altair 1250 chipset, and really provide the same security level as a classical SIM. And really, as the most straightforward benefit that has driven a lot of new application is really the size, right? Huge size into the necessary footprint to basically enable a cellular device. So one thing that we've also heard quite a lot in the recent months and close to years now is also the massive semiconductor chip shortage that we've been seeing. And actually, this was particularly in some ways impacting the SIM industry. And the reason behind that was that the SIM industry was using, I would say, so-called process technology, the size, basically size of the chip, you would say, slightly higher than the typical, most recent smartphones or integrated chipsets for cellular. And the capacity was even more drastically reduced or under pressure for those type of technology. So in a sense, iSIM is also bringing an alternative option. It doesn't solve all the shortage problem by far, for sure, but it gives another option to consider for OEMs going cellular and making their choices on the technology that they need for enabling that connectivity. So yeah, in that I would say ecosystem, Kigen is focusing on delivering the embedded software then run into SIM, eSIM, iSIM, and also the associated services, which are, for example, digital key insertion, data generation, so that the operators can load their credential onto integrated SIM during manufacturing or over the life cycle. So moving to the next slide, one of the key aspects of iSIM is that it does changes the supply chain of the SIM function into a device. And really what I want to picture with this slide here is that it's an OEM-centric ecosystem. Kigen is a spin-off coming from ARM in 2020. And we've been scaling the original SIMULITY business with a lot of investment into data centers and staff and expertise to basically really enable and leverage the ARM ecosystem that gave us access to a large number of key players, notably on the hardware side. And you see those at the bottom of this slide here, right? ARM has historic relationship with the hardware secure enclave provider, the companies such as Synopsys, Tiempo, ARM itself, who deliver embedded hardware security IP that a chipset provider can integrate into their product to provide security function. So that's really the root of the trust inside a cellular chipset and device. Then a company such as Sony Altair, who's really dedicated to provide the best chipsets available for LPWAN, can build a chipset embedding those functionality and work with Kigen to integrate, for example, the iSIM OS. Then those chipsets get integrated into a cellular module, the likes of Murata, Sercom, Quectel, and so on. And so here, all these three players are kind of hidden in the background, and that's the pre-work that we done in the iSIM ecosystem. Ultimately, for an OEM, all they should really care about is to select hardware provider, and most of the time it comes in the form of a cellular module vendor, especially for IoT. And they also select the right connectivity for their needs and their use case. So they have a relationship with, let's say, an operator, an MNO, an MVNO, or a set of them, right? And so here, our role as an iSIM vendor, and Kigen in the blue box that we see at the top, is really to enable the glue between the connectivity supplier and the hardware ecosystem, right? And to do that in line with the GSMA requirements. So how does that help specifically for micromobility? Well, first and foremost, right, compact size. The kickboard is a very constrained small space, right? The smaller the electronic parts and the more reliable and solid it can be, the better, right? And there is also a TCO aspect to this. So it also provides a clear, secure connectivity to the network. But what we can add on top of that is really to enable what we call smart data. That is doing more intelligence at the edge, right? For the OEM who build this type of devices, they can build in the sensors, collect the data, transform it locally on the device, and then securely transport it back to a backend data center to effectively provide insights, provide more value to the end customer and to the fleet manager. And I would say to expand a bit on this generic concept is following the GSMA intelligence study that was done back in December 2020, we had an impressive result that 98% of the companies who were interrogated really wanted to focus on chip-to-cloud security, end-to-end security. So the iSIM is here to provide a secure connectivity to the network, but not only, because this secure enclave, this secure functionality can be used for the application itself. One good example of that is GSMA IoT Safe, which is basically enabling chip-to-cloud TLS security, right? Really from the device all the way to the back end of the hyperscaler, for example, such as AWS or Azure IoT as an example. And here we did a lot of work preemptively, again, with the ecosystem concept to say we work with all the key secure stack provider, the TLS stack provider, to make sure we pre-integrate the technology as much as possible. And we pre-integrate it also with the RSP functionality. So with that, I mean, smart data for smart cities, what can it mean with, for example, IoT Safe? That can mean provide the metadata from the vendors. Where are we with the battery charge level? Where are we with the different service level in the offering of the vendor of micromobility? Providing calculation on how much CO2 is saved, provide safety information, safety data, etc. So really to enable, I would say, more insights into the actual usage, whether it's for the end user actual benefits directly or for the fleet manager. And really, that's where more processing at the edge on the device requires, in a way, more security, more protection, because the vendors are spending time and effort to differentiate themselves with those features. So with that, thanks a lot. And I will pass the baton to my friend Igor at Sony Altair, who will talk about really the chipset and module aspects of things.
Thank you, Loic. Hi, good afternoon, good morning, good evening, everybody. My name is Igor Tovberg. I'm from Sony Semiconductor Israel, responsible for the product marketing. And today we'll speak a bit about cellular IoT solutions for the micromobility market. Let me try and share a couple of slides with you. Okay, it's supposed to be coming. Okay, good. So before we getting a deeper dive into the right technology for the micromobility, let's try to understand what kind of technologies we have these days. And let's start with some history of the cellular technology. Back in 1980s, there has been a first generation of cellular. First generation came a bit later, let's say 10 years later. The second generation, the GSM, came, and this technology introduced the voice and text capabilities. Later on, about 10 years later, we got the third generation of cellular connectivity that came and brought the circuit switching voice data, and we could also firstly deliver the data over IP. And a bit later, in a decade later after it, roughly in 2010, we got the standard which is being widely deployed these days. This is the LTE. With the LTE, there are several categories exist, and these categories are called Cat 1, Cat 3, Cat 4, Cat 6, and higher categories. And the difference between these three categories is higher data throughput. The higher we go with the category, the higher data throughput we are able to deliver. The higher data throughput we deliver, the more powerful chipset should be, and the more power this chipset should consume. Looking at this landscape of technologies, we realize that higher consumption chipsets are not the optimum fit for the smart mobility market, because we are not expecting to deliver gigabits of data from a smart scooter. We expect that the battery life of the tracker device in a scooter would last for weeks or even years, and not will be depleted just after one day of operation. And this is why we think that the right technology for the smart mobility will be the two technologies that has been specifically designed for cellular IoT devices, which is called LTM. This is the Cat M1 technology, and the second technology, this is NB-IoT. So these two complementary technology that has been widely deployed, and I explain in the next slide about the global footprint of these technologies, are the optimal technologies that brings already these days in connectivity for smart mobility. Looking for the next generation of the 5G, this is the next generation standard of the cellular, which is mainly focusing on the broadband connectivity, and then brings in significant enhancement of the data throughput devices. But there is also an intermediate technology which is called NR RedCap. This is the reduced capability new radio, which comes to replace the existing LTE Cat 1, Cat 3, Cat 4 devices, and this is what will be used for devices that are supposed to deliver throughputs in a range of from a few tenths to 100 megabits per second. But if you're looking at the same space of ultra low power cellular IoT devices that does not require high data throughput, there is no equivalent in the 5G rather than LTM and NB-IoT. So these two technologies will exist during the 5G era, and our expectation that these two technologies will be staying after the 2G sunset, 3G sunset, and even after the 4G sunset, after LTE will be shut off, the LTM and NB-IoT will stay and will be supported by the MNOs. If you're looking at the next slide, in terms of the global footprint of LTM and NB-IoT coverage, we see more and more MNOs operating these two technologies, and it has been a significant growth, about 150% that has been growing since the last 3 years in terms of the coverage globally. Some of the MNOs still using LTM, some of the MNOs are still using NB-IoT, but the trend, and this is the global trend that we expect to cover the entire globe, will be a support for both technologies, LTM and NB-IoT. And this is why we think that the only chipset that is viable to operate for micromobility is not a single mode chipset like LTM only or NB-IoT only. It's supposed to be a chipset that can support both technologies because such device is supposed to be shipped globally, and we expect that until the coverage will be equal in terms of both technologies, there is still a need to support both LTM and NB-IoT. So what are the needs for the micromobility applications? We classify the micromobility for two major segments. The first one is the shared micromobility, and the second one is the personal, the people that is buying a smart bike, a scooter, and using it. And then the shared mobility, this is the company which is procuring the scooters and licensing, leasing the scooters for third-party use. So for the joint part for these two verticals is actually there are few items. First of all, global coverage. As I said, the scooters supposed to be manufactured by some vendor and supposed to be shipped globally. There should be a global coverage as the same device supposed to be operated globally. Long battery life, we would not expect the device will be recharged after a few hours, and we would expect that the tracker, which is located inside of the smart scooter, will be using not necessarily the same battery as the battery which is driving the motor of the vehicle, but will be using a separate battery. In case the main battery is depleted, we want to have an ability to locate the scooter. Location services, either GPS, GNSS-based services or satellite-based location services are both needed. We would expect that device will be providing a very high level of security because once we are using the shared mobility, we provide our credit card, and we expect that the data that we provide will be securely stored and delivered to a server that will be charging us for the usage of the vehicle. The security is very important. Small size, as you can see, the tracker in some of the cases could be integrated in a frame of the bike. It could be integrated or hidden in some of the places inside of the scooter or bike, and this why the small size is highly important. Of course, the cost is always a big issue, and here the devices that supports lower categories of LTE comes to address the needs of cost-sensitive applications. And of course, the built-in connectivity, this is something that the integrated SIMs are providing, and this is something that we deliver already these days commercially with our solution. A few words about the chipset, which is being powering these days already several smart mobility application, and it has been deployed and operated in millions of devices these days. The chipset is called the LT1250. It supports multiple features like the multi-route support. We provide LTM and VRT and also 2G fallback option. There is an integrated MCU which is fully allocated for user applications. The integrated SIM that may come with the pre-integrated connectivity, and there is absolutely no need to host at the same tracker device any plastic SIM socket or an eSIM. For the power consumption, we provide this chipset for a wide range of applications, and it provides, for example, for the smart metering applications, it provides more than 15 years of operation. Of course, for the smart mobility, it would last months and even years. Integrated security is inside. We provide integrated hardware GNSS and also cellular-based positioning. And all these features are coming integrated in a very small size of modules, while the smallest module could get down to 10 by 10 millimeter. And at my last slide, I just want to show with you some of our module partners that has been using the integrated SIM already these days, and these modules are available for purchase. And as I said, the integrated SIM solution is a commercial grade, and multiple devices has been already commercially operated globally. With this, I would like to hand over to Ronnie. Ronnie, to you.
Thank you very much. So thank you for our ecosystem partners and friends. I'm going to share a few slides, and thanks for Neil and Counterpoint for hosting us. So I think our slides have joined. Neil, is that they're all right? Can you see them? Okay. So yeah, thank you. So we are looking at this sector, at the micromobility sector, from the connectivity point of view. You know, FloLIVE is the connectivity infrastructure for devices, mobile networks, module manufacturers, and device manufacturers. So we will be looking at with a spotlight on the micromobility, and with everything that we've just heard from Sony Altair and from Kigen, I think that's quite, we have a lot of information here, and it's all sort of, from our point of view, comes together with that connectivity. And I will go through a few slides of that, hopefully get some context. So from a connectivity point of view, micromobility has these sort of 5 real key elements for us. And uniformity really is this, when we talk about a single SKU, I think everybody understands it. We cannot manufacture, the OEMs cannot manufacture various types of devices. That comes from, from the connectivity all the way to manufacturing, the availability, having that connectivity available always, the cost saving. I think we've all touched on that in both our previous sort of from presentations here. In every element, from the manufacturing and the SIM, the embedded SIM, the cost savings, that's also part of why we're integrating the connectivity inside these devices. And obviously the low footprint, we've discussed that, it's a key factor. And I think, not to leave it to the end, but security is becoming a major factor. And I think we all want to touch upon that. And we will explain why and how we deploy security in a way really that is highly secure between these ecosystem partners, from the SIM all the way to the core infrastructure. I'll touch on each one of these sort of items. Really, a single SKU and a single integration is a very key factor for the manufacturers. Really a way to manage and deploy and provision these devices and deprovision these devices when they're in the field. So there's the scooters, there's various forms of these bicycles. Again, we touched on a fleet, or we touched on personal, even a personal device would like to perhaps stop the device, understand where it is in case it's been stolen, etc. And with regards to security and latency, I think this is a key factor, and I think this is how we show how we do that through our FlowNet platform. And we do that through infrastructure that's deployed across the globe, our own core network infrastructure, and packet gateways that are spread around the world in order to provide that low latency solution that these devices need. And last point on this one is sort of a one government strategy. The way we would do governance on that is that our customer would really want to know that all their devices are compliant in the same way in every part of the world, that there's no, in one part there's less security, another here they get a consistent security across, and that's how we provide that with our FlowNet infrastructure. The next element is the availability, where we're discussing how, just heard from Igor about how important it is to have, narrowband and LTE-M or both. I think this is where, the item of availability, having the low power coverage, FloLIVE has this infrastructure today with many mobile networks around the world, and I think covering more than one mobile network in a single country is an extremely important element for a fleet sort of leader, because in case that the device fails, I think we always want to have a fail-safe, a way to get access back to that device. And extensive coverage, I think we're covering the US, China coming soon, Europe, with narrowband and LTE-M, working together with both our partners here on this. I think it's very, very important for fleet manufacturers, for the manufacturer, or fleet operators, I would say, not fleet manufacturers, fleet operators, to have that global coverage and to know that when they're deploying those devices, there's always going to be coverage. I think a lot of the manufacturers, not just in this industry, will tell you that the 90% of their problems is always when the device is in the field, that's when their problem starts. I think that's something that we're trying to eliminate with global infrastructure. The cost savings, well, I guess that comes across, on one side from the chip side and how it's small, etc. But in terms of the connectivity side, there's the local rates. So local carriers typically have better rates than roaming. We obviously all know the issues with permanent roaming restrictions. There's certain GDPR data that comes along with that. So definitely flexible for cost optimization when we could move between various profile on the SIM, on the integrated SIM, use various different carriers in order to build a better cost optimization. With our technology on the SIM, we have a multi-IMSI application running over our UICC. So we could switch with zero transaction fees between the carriers and keep switching them back and forth with zero transaction fees, which is really important. And, if we're looking at charges of regular UICC swaps, they're heavier in terms of the data consumption, but also there's definitely a big issue with costs on that. And I think anyone who's looked at switching profiles just for a small amount of time will understand that that's a cost factor which is probably not valuable for this. I think touching a last point on this, an enterprise self-service, I think we all want to monitor and troubleshoot. I think we want to give the enterprises much power in order for them to troubleshoot, manage their fleets. So I won't touch more on that, but definitely something you can talk to us about if you'd like to see the enterprise management suite. The low footprint, I think we discussed that already, but just touching on that from the SIM form factor, it's an evolution, prolonging the battery life, the small form factor. I think from our point of view, really, it's the local network breakouts and the fact that we can now add over the EUICC profile, add our multi-IMSI application and run, multiple networks on that profile. I think that is where, for us, that ties it all together and gives that capability to those fleet managers to optimize, to get greater coverage, and for the manufacturers to know that if they're shipping it out, it's always there. It's always connected. Security, definitely, probably most important. Yes, perhaps it's a money saving, not a money making. Definitely an element that we're all looking at. We all know that the IoT devices are much harder to look after in terms of safety. They don't have that power, perhaps, but we're looking at end-to-end security, and that's how we do it. We do it both from the SIM to the core network to the billing and the management. Having that element of our own infrastructure around the world, these, I think perhaps a difference between FloLIVE and many other partners around the world for connectivity is that these devices are connecting to our infrastructure, meaning that we have the handle on one hand from the SIM side and the application running on the SIM to the core network that's authenticating that. And then further elements on that is various elements around the billing, where we're looking at, all the way down from signaling management and DPI, and all the way to managing these fleets. So we're looking at end-to-end security as a key element. I think one other thing, perhaps it's not as many people may not be aware of this, but we're working together with our SIM vendors here, and Kigen being a key partner for us. When you manufacture a fleet of SIMs, we are able, because we're running our own infrastructure, we are able to provide our enterprise partner with the capability to change the keys on the SIM card. So there's nobody else would know them apart from our partner. I think that's a key element here, where I haven't seen this widely available in the market, and I think it's a very, very important element that we could provide as an extra layer of security. No one knows what it is, what the keys are, apart from our partners and our infrastructure. Globally secure, so our infrastructure really has the same level of security across the regions. All our packet cores, our packet gateways are all managed in the same way. So our partners know, our customers know that when we're using the infrastructure, our connectivity infrastructure, it is really the same level of security, and all these core networks are integrated. I think from a fraud prevention, perhaps it's not the latest new invention, but definitely real-time billing and rating systems are not 15 minutes delayed, like many of our people from the industry would know, getting CDRs later on, 15 minutes later, and trying to detect them fraud attempts. Here, there's real-time billing. It's all running on our own packet cores, so there's all this real-time billing and an ability to shut down automatically without having that intervention. So I think touching on those 5 elements, I'd like to I'll give one. I think some questions may come up. So a little bit about our infrastructure. A globally distributed set of core networks in key regions around the world, from the Americas, Europe, and Asia. It means this is our own infrastructure, our own core. I think this is probably, to date, one of the largest global spread out infrastructures of cellular, specifically targeted for the Internet of Things, for devices. All the core networks are centrally orchestrated from the cloud, so all our infrastructure is the same and it's centrally managed. We are connecting to various MNOs in each country, and where we have infrastructure and growing infrastructure all the time. And those IMSI ranges from these MNO partners reside on our Flow core infrastructure. So these devices, when they connect to our infrastructure in country, they're authenticating on our core, but with the local MNO. And I think that covers many of the elements that I discussed earlier, like GDPR, some in various, and perhaps in some countries, financial sector. There's the issues of data sovereignty, Definitely GDPR being a key element, but we are, I think that is one thing that's covered by the local IMSI. And our standard inter-carrier integration, I think that's perhaps if there's MNO partners on this presentation as well. It's a carrier standard integration SS7 SIGTRAN diameter, and a set of REST APIs for our partners if they would like to connect it to the end user apps or to their management platforms. I have one slide for a case study. So we have a customer of ours, a manufacturer, e-scooter company that has a global business, wants to expand in every region, wings, and they're working today with us to get global coverage, a single SKU, real-time visibility for their management. We do their factory testing as well, so they can, before they leave the factory, there's an ability to have a small amount of data run, make sure that their infrastructure is getting the data from that single device, then packed, shipped out to where it needs to go, and when it gets to its destination country, it gets that connectivity and it's back on the management suite. Self-care, part of that management suite, local MNO support. So there's no point in taking hours of problems to start calling an MNO, finding out what's going on, why is it not connecting, where is it right now. I think all that data is available on our management portal. I think with that, Neil, if I'm still on time, I would say if you have any questions, you'd like to work with us, you'd like to understand more, we would be very happy to help. Our teams in the US, Europe, and Asia, Bill Work going from the US, Benny Einor in the UK, sorry, in Europe, in EMEA, myself in the UK, and yeah, we'd be very happy to work together, ask any questions. I think that's it, Neil. Is that my own time?
Yep. Thank you very much.
Thank you very much for that. Thanks for being part of the team. I will turn off this.
Great. I think we can dive into any questions we have from the audience, and also we can have a discussion around how this entire solution fits together. We have seen how iSIM integrates into the chipset, and chipset connects different devices with a single SKU possibility and global connectivity, global common infrastructure. So obviously there are some questions around it, how this all works together. So maybe the first question we are getting is about the TCO. So maybe if you guys can touch upon the total cost of ownership on deploying this particular solutions across the board for the customers. Loic, if you want to go first.
Sure. Yeah. So obviously, I think the TCO is a very interesting issue because quite often this TCO is seen from two perspectives: the hardware side by one person, the buyer, right, of the hardware, and the connectivity side of things, right? And to me, this conversation should be elevated a bit and reach the CXO level and say, look, what's the actual total cost between hardware and connectivity combined, and what makes sense? Maybe if you differ a bit of costs towards the later part of the investment, that might reveal itself as a better deal. Or maybe Ronnie touched upon, RSP costs. These are coming down, but that's something to factor in. And depending on the number of transactions you might think you'll have to do, you might decide to say, I'm going to use RSP or multi-IMSI or a combination of both, right? And we've seen a lot of combination of both in the late part. But my personal estimate, right, is the TCO of the SIM and its life cycle, manufacturing, inserting into devices, replacing truck rolls, etc. It's a $5 to $10 equation, and sometimes people say it could go even above, right? So I think the iSIM has the capability to reduce significantly that TCO base. Now, really, my advice to listeners and integrators is to say, look at the big picture and be inclusive of hardware and connectivity end to end.
Fantastic. Great. maybe Ronnie, if you have any comments to add from infrastructure.
I think, I think thanks very much, Loic. I think on that, when we look at connectivity as part of a TCO, I think the business model is the one that is changing, and we've adopted a business model that is adopted for the Internet of Things, for devices. And I think, without going too much into it, the business model is the fact that, you know, everything is pooled. You only pay for the data that you use, and instead of getting into long-term contracts per SIM, etc., I think it's very difficult for an OEM or for a fleet operator to start building businesses where some devices may be faulty, some cities may be working better than others. So I think from a global connectivity, we've adopted a business model that's fit for the Internet of Things, and specifically for the micromobility. I think it touches upon everything and not just micromobility. You know, paying for what you're using, pooling it all. I think that's for me, that's the key part of the TCO, because otherwise, I think the worst thing would be paying for things that you're not using, and you're not making income from. So I think for us, that's the adoption to help a TCO. Adopt a good TCO.
Igor, do you have any thoughts on from the module and choice of connectivity perspective? You touched upon that, why LPWA is right fit.
Yeah, so I just want to touch one point on the TCO from the hardware perspective. When the customers are usually trying to count what the plastic SIM versus eSIM versus the iSIM cost, you know, it's not always a direct cost, but some indirect costs, like the cost of the PCB, for example, that should accommodate the SIM socket, and this real estate cost money. So it's usually not counted, or maybe it's counted in a later stage when the device is already in a quite progressive and advanced stage of development. So this should also be taken into account. The logistic chain, the procurement, all the margins in between, the shortage that we have these days in the industry, and the prices for the eSIM components are sky high. So all this should be taken into account and calculated into the TCO. So it's not just a hardware, it's not just the software, it's not just the connectivity, it's the TCO.
And so another important point which all of you touched upon was security, right from SIM chip to cloud infrastructure. Can you touch upon how this security is integrated, and whether it is GSMX standard grade, and are the fleet managers and all rest assured in terms of security of the data from endpoint to the cloud?
Yeah, so I may start answering this question, and maybe my colleagues to complete it. So first of all, in terms of the hardware security, we have the integrated secure element, which is playing the iSIM role. This integrated secure element has been accessed by multiple parties and has been found as highly secured, and it provides the same level of security as the standalone secure element or standalone eSIM or plastic SIM, so there is no security concern from this perspective. As for the cloud-based security, so like you may tell a few words about it, how possible to use the IT safe type of applications for cloud-based security. You're on mute.
Sorry, yeah. Just on that, I think really the key benefit there is that now a secure root of trust becomes available on many more devices, right? And it's up to the OEM to benefit from this opportunity and say, I'm kind of owning the security of my devices. it's enabled for telco security, and they can leverage, connectivity player specific offering in security, but they can also have and own their own keys that only them really know and deploy, so that they can have the peace of mind that effectively they provide chip to cloud security from their assets to their infrastructure, and they can have this overlay there. So I think it's really important to see that opportunity. Before, with a plastic SIM, you were dependent on whatever was included in that plastic SIM from the connectivity supplier.
Yeah, I mean, I won't go through all again, but I mean, from our point of view, it's all about the end-to-end, from the SIM to the infrastructure. We get a lot of data along the route of the authentication, the SS7, the routing, obviously the billing. But when the data also moves from ourselves, from our packet cores to the customer's IT infrastructure, there's a secure element between between the packet cores and that IT infrastructure of the customer. So the end-to-end, which what I was saying before, probably was at our infrastructure, it also is key to touch upon from ourselves, from the connectivity all the way to the IT infrastructure of the customer, whether it's VPNs, whether it's more tokens, whether it's extra security and more cloud-based. We have to be challenged with more cloud-based IT environments today the end customers are using. So there's a lot more security actually that is happening between the packet cores and those clouds, and I think it's a benefit. It's a benefit to our partners, our customers, and I think all around the table here, big touch on security and what we could have done. What we've done with Sony, what we're working with Kigen on those applications inside. I think it's taken some time, but we've definitely worked together on this, and I think. Just to one last sentence is people said a lot that this is going to be an ecosystem play, and I think in this case we've really proved it, that it's a good ecosystem play between the hardware, the SIM, the connectivity. I think it's definitely proven itself.
Absolutely, IoT is all about partnerships and ecosystem play, and that is where you get the benefit of TCOs, end-to-end security optimizations. As well. So there's one more question. Maybe it's for you, Loic. What is the plan for supporting RSP on the iSIM? Without the RSP ability, it seems risky these days to use iSIM over an eSIM given that limitation. And yeah, means GSM is also working on that. So maybe you can touch upon.
Sure. So I think two first important points there is on the embedded side, right? You have already everything defined at GSMA to certify an iSIM to be RSP capable, right? So that's GSMA calls an iSIM RSP capable an UICC, integrated embedded UICC. Right? It's quite a mouthful, but effectively, if the hardware meets the requirements set by GSMA, it can also be certified for RSP functionality, and there are a certain number of already players delivering this type of roadmap and functionalities. So that's for the embedded side. Now for the server side, there is a group called the Working Group 7 who's also working on how to enable remote SIM provisioning over LPWAN network and really adapted to, I would say, the new type of LPWAN devices. And today's RSP, M2M or consumer is not suited, I would say, for LP1 RSP. And so this working group has already defined a spec. There is an architecture spec available since March and planning to have a full specification complete by end of the year. And basically it introduced two key concepts: removal of SMS dependencies and introduction of a lighter transport adapted towards LP1. The industry, right, and Kigen is the leader of this working group. Our head of standard is the chair of this group, has already agreed that it would use SMTP+ as the key element, so that we can also, from an MNO standpoint, reuse already deployed infrastructure with SMTP Plus used, for example, for consumer smartphones, right? So there is clearly an agreement already on that. And Kigen has also been demonstrating LPWAN RSP to multiple interested parties. So feel free to contact me if you have interest, because we are working on the pre-standard before IoT RSP available. We already want to implement this in the field and make sure it works before having a spec. And I'm really big on that. Say these standards need to be pragmatic and implementable.
Great. I think this is a great discussion, and I'd like to keep on going for next hour or so as we get warmed up. But I think we'll have to end this session right now. Thanks to everyone joining in from everywhere around the world, and thanks to the panelists and the speakers, Floyd, Ronnie, and Igor. Very insightful. Always great to learn new technologies, how they are changing the landscape, and from cost perspective, security perspective, as well as applicability perspective. Thank you very much, everyone joining in.
Thank you, everyone. Thank you, Neil, for hosting us.
Thank you, Neil.
Bye-bye.
Thank you, everyone.
Take care.
Bye-bye.
Cheers, bye.
Bye.
Yep. The presentations will be available for everyone who have registered for the event. Thank you very much.